This video, we're going to go over the closest binary search tree value. This is a relatively easy problem if you know what a binary tree is and you know something about recursion. If you don't, this is a pretty tough problem. So you can read my code and try to figure out what I do here. For those of you that need more explanation, please keep watching the video. You can read the definition here, but basically, a binary search tree is a data structure where the left node is always smaller and the right node is always bigger. That's about it. Now let's look at how we can construct a tree node in Swift. So I have a class tree node with left and right tree nodes and then a value. So we have a root at 4. So how do we get to node number 1? So we're gonna go to 4.left. So we go to left twice, and then we can access the value by dot value. This is basically how you construct a tree node. It's pretty simple. One of the easiest way to understand these type of code questions is program it inside your Xcode, not Playground. Just create a regular project so you can put breakpoints and see what the app is doing. So running my code, I'm constructing the tree just like the example, and then I'm gonna find what's the closest value to 2.6. I'm gonna find that node. Let's see how the code goes. First, we gotta check if the root actually have anything. If there's something, we're gonna call the recursive function. DFS is short for depth first search. This is the type of recursion called depth first search. It doesn't really matter what you call it. It's basically just a recursion. You're gonna go through all the nodes using recursion. So the first thing I do is check if the node actually exists. You'll see why later on. And then I make the closest variable into a mutable variable so I can change it later. At line 54, we're checking the target for our current node. See if this is the closest so far. If it is, we're gonna assign it to closest. After checking the current node, we have to decide, should we check the left node or the right node from this tree? We know that the right side is always bigger and then the left side is always smaller. So we just have to compare the current value with the target value and decide where to go. In this case, we end up with the left subtree. So now we're going to call DFS again, and then we're gonna end up in the node with value 2, right? So we have nested functions. We have a DFS in node number 4. That's calling DFS node number 2. This is what you call a recursion. You really have to understand this because at the very end, we are gonna passing the value from the innermost function and then try to pass it out one level at a time. So we're doing the same checks. We're at node number 2 on the left side of the tree, and we're gonna see what's the difference between this number in node number 2 with our previous number. If the distance is closer, we're gonna save it to the closest variable. Now we're gonna do the comparison again. Since our target is 2.6 and our current node is 2, so our target is larger, we're gonna go to the right subtree. So we're gonna call another recursive function. So we have 3 nested functions. We're at a node where the value is number 3. Now we're going to do the same checks again and find out if this is the closest distance in comparison to the one before. And we are gonna end up checking if 2.6 is smaller than 3, which it is, and we're gonna call the left subtree. Because we're at the bottom of the tree, there's nothing on the left. So you're gonna be passing a nil to the function. So your next recursive function will be getting a nil node in which it will return the value back. Since this is a recursive function, once it get to the end, it's gonna pass the value back to the level before it, and the level before it gonna pass a value to the function that's above it, so on and so on, till the function gets the final result. So there's like less than 15 lines for this problem. The hard part is try to visualize how the recursion work and how value is passed to each level. The best way to understand this, if you don't, is use a compiler and put breakpoints. When the value is returned, check the no value of your current level so you kind of know where you are, and check your closest value and what value you have, and then just keep doing that. Eventually you'll get what's going on with the recursion. If you find this video helpful, please like and subscribe. I'll be making more videos like this.